Let's do this!
It isn't.
'Cause I'm going all the way down to my walls. Best believe what you've been told.
Oh, yeah. We're all scared. But we get through it because we're not alone. Who do I have? Me, you dumb shit!
3, 2, 1.
Now is your chance to prove yourself.
Locked and loaded!
You want to finish laughing? I don't want to stop you.
Whoa! I can't believe you did all this for me.
I did this for everyone.
Hey, what's up? Hey everybody, thanks for coming today. Thank you to Netflix for hosting this Druid Meetup. It's an honor to be here at Netflix. Actually the very first open source Druid user. A little bit of Druid trivia there, and Netflix trivia there. They actually used Druid about a month before it was open source when they first started using it. So thank you Netflix for hosting and for supporting Druid for its entire life cycle. I want to talk a little bit today about what Druid is for any of you who are not super familiar. First off, show of hands. How many folks here are familiar with Druid? Awesome, a lot of people. How many of y'all are using it in production? Okay, cool, about half as many. So yeah, so Druid is, it's a fast analytical column store database designed for interactive slice and dice analytics, most commonly used for interactive apps, OLAP, that kind of stuff. Integrates really, really well with Kafka and with Hadoop. So whether you're doing streaming stuff or batch stuff, get your data into Druid, do really fast slice and dice on top of it. Any of you that are still paying attention at the end of the talks, I'm going to be doing a little talk about the roadmap, community update for Druid, talking about our next couple of releases. So if you're still paying attention then, hear about that stuff. And then afterwards, we'll have drinks and happy hour and a little more food outside. And without further ado, I'd like to introduce our first speaker from our host at Netflix, Samarth Jain, who will be talking about some of the use cases here that they're using Druid for.
Hello, everyone. So I'm going to be talking about the Druid deployment here at Netflix and the various use cases Druid enables and serves. So, and just an overview of my presentation, I'm going to be covering what role Druid plays in our warehouse, how we get data into our Druid clusters, how we deploy Druid here at Netflix, and finally the use cases. So this is what roughly our Netflix data warehouse looks like. We have devices, user devices, client devices, and we have internal microservices which are sending in event data that are processed by our Kafka pipeline. We call it Keystone. These events are then picked up by another service. We call it Ursula, which basically batches these events, demultiplexes them, massages them before writing it out to our warehouse S3. Then we have dimension data flowing through our Cassandra clusters. We have a service called Caspactor that is reading daily backups of this Cassandra cluster, the SS tables, and writing it out to S3. As far as the various computation engines, the big data computation engines that we use here, we use Spark heavily for our ETL workloads. Of course, we're on Hadoop clusters. We have some legacy use cases that still use Hive and Pig. We extensively use Presto for ad hoc analytical queries. And Druid is used for running analytical queries on pre-aggregated data, where you want like interactive response times. So how do we get data into our Druid clusters? The primary way we use for ingestion is the batch injection. We use Druid's Hadoop indexer. We use S3 as our deep storage. Our input is mostly, well, it's primarily Hive, and the data is stored in text and Parquet format. So this is sort of the flow of how data gets into from S3 to Druid. So we have what we call a big data API. It provides a really convenient way of letting users say, this is the input table I want to ingest data from, this is the spec I want to use, and this is the cluster I want to run it on, those kinds of things. API interacts with our orchestration service, Genie. Genie is another Netflix open source project. It's a big data orchestration service. It takes care of running jobs on our clusters. In this case, Genie kicks off the Druid Hadoop MapReduce indexer job, which then pulls in data from S3, generates index segments out of it, publishes out the metadata to the RDS, which is part of the Druid cluster, and eventually the Druid cluster ends up downloading the segments from S3. So this is I would say, pseudocode, but it actually closely resembles what users do for getting Druid data. All they need to do is using a big data API. So all they need to do is they declare, they just say, this is the table I want to ingest data from. Use this kind of spec, just provide the JSON file for that. And tell me that I'm going to run indexer job. This is the cluster I want to use, and execute, and boom, done. So what does a Druid cluster looks like at Netflix? We are using the R416X large instance type. We recently migrated to R416. For the longest time, we were using R38s. We run the 12.2 version of Druid, and our cluster is some hundreds of nodes. As far as the multi-tenancy story is concerned, we use a single tier of historical nodes. It has been working out for us so far. Cost hasn't been a concern. We have deployed router, the router component of Druid, which is backed by 3 sets of brokers serving different kinds of use cases. So we have the ad hoc broker, which serves various ad hoc user queries. We have the experimental broker, which users use for fine-tuning their queries, where somewhat it's possible that the broker would come down. So downtime is acceptable there. And then we have the reporting broker, which is what all our dashboards and predefined user queries hit. How do we auto-scale our clusters? So this policy was in place, has been in place since we had R38s. And R38s have fixed disk. And so the way we would scale up is we would monitor the average disk utilization across the cluster. If it's beyond 80%, the policy would automatically go and add more nodes. So if any user ends up adding a lot of data to the Druid cluster, the policy would just cause our cluster to scale up, and we don't have to worry about the cluster falling over. How do we deploy Druid? This is how we do it. So we use another Netflix open source tool. It's called Spinnaker. It's a continuous delivery engine. And so for this, we have created a pipeline in Spinnaker. What we do is we first build the Druid package, which includes the actual Druid code combined with the Amazon image and the various Netflix specific configuration that we have. We take that and we deploy we deploy the various components of the Druid cluster. So historical, coordinator, broker, router, overlord, etc. And then we wait for historicals to download all these segments. We monitor the coordinator as when all the segments have been downloaded, we enable the new cluster, which is nothing but saying switch the DNS records. And so once we enable all of these, we publish the new cluster, and then we wait. We wait for like a few hours to make sure there are no regressions, there are no performance issues, user not running into errors. Once that is done, we say everything is fine. We just scale down the old cluster. So this comes in handy when we have to roll back. Let's say if the new cluster is acting up, all we need to do is we need to switch the DNS record back to the old cluster, and we have a rollback. So what kind of use cases does Druid serve here? The primary use case for Druid at Netflix here is as a dashboard backend. where users want to do a lot of slicing and dicing of data. And they expect very interactive query response times. Some of the use cases, they explored Redshift, but it turned out that the queries were not running fast enough. And so they either had to reduce the amount of data they were storing in terms of time, or they had to reduce the dimensionality of the data. Druid doesn't have a very good user interface story around it. So what a lot of teams have done here is they have built custom user interfaces and dashboards. So in the next couple of slides, I'm going to show you a couple of use cases. And a lot of stuff is grayed out because it's sensitive information that we cannot show. But just to give you an idea, the various kinds of use cases that Druid is enabling. First is we use one of the dashboards. We use it for AWS capacity planning. And so if we have to monitor the cost of our EC2 infrastructure across regions, across instance types, by accounts, by zone, by region, etc., this dashboard provides that information. So it's very easy for users to just slice and dice if they want to filter by instance type, if they want to do it by platform, Linux, Windows, etc. This is just super fast and very interactive. The other use case that we use is our A/B testing platform. So in this case, you can think of cells as experiments. So experiment 1, experiment 2, experiment 3. In this particular use case, they have aggregated data across these experiments, right? And so if they want to see for experiment 1, what are the metrics, experiment 2, what are the metrics, etc. And then they can do further filtering once they have on that aggregated data. Again, classic slicing and dicing, very fast. There are other use cases here, which unfortunately I'm not able to show you the dashboards for. But to give you an idea, one of them is a payments analysis. So we have our payments platform where we have different kinds of payment instruments. You can pay through credit card, you can pay through PayPal, etc. And so this platform basically tracks the performance of these payment instruments across all the countries where we stream Netflix. Then we have dashboards that compare performance of algorithms. So our data scientists keep running different algorithms all the time, and how to compare performance, they have Druid dashboards running for that. We have some use cases that basically are used by a security team, where they want to monitor the security infrastructure that we have. And then there are some dashboards that target a quality of experience. By quality of experience, we mean the quality a user is experiencing when they're streaming Netflix. Vivek is actually going to dive more into that. So we have some future work planned here for Druid. One of them is real-time ingestion. So we have a few use cases that are coming up that want to ingest their real-time data into Druid. As I said before, it has been so far a batch indexing mode for us, but now with use case coming up, we're exploring whether we should be going down the route of using Tranquility or Kafka indexing. Tranquility being the push mode where users write jobs and they push data over to Druid. Whereas Kafka indexing, where the users just provide a spec and then Druid's Kafka indexing service ends up pulling the events and generating indexes out of it. We have been extensively using what we call the Netflix histogram module, Druid module. Internally, it uses a T-digest. It's used for building sketches and making percentiles. Again, Vivek and Matt are going to get in more details there. And we have plans to open source that. We are investigating tiering. As and when our usage grows, we expect our costs to go up. And so we want to investigate tiering and see if it can help control these costs. And then we want to possibly change the auto-scaling policy. With R416s now, we want to see what can be done now that with elastic block storage disks. And with that, I would hand over to Vivek.
Thanks, Samarth. Hey, everyone. I'm Vivek Pasari. I'm a data engineer here at Netflix, and I'm going to talk to you about client performance metrics and how we process a large amount of data to give our engineers and science and analytics folks insights into Netflix client performance behavior. So let me tell you a little bit of a history, not too much of a history lesson. Only 3 years ago at CES Las Vegas that Netflix announced this thing called Netflix Everywhere. It's basically, we launched Netflix in 130 additional countries in January of 2016. And we were already in 60 countries at that time. There was, that brings us up to like about 190 countries. So basically, anyone could go, virtually anyone around the world could go onto Netflix.com, sign up, and start streaming movies. And that was a really exciting announcement, Netflix available everywhere. Needless to say, that presented quite a challenge to our colleagues here in Los Gatos. This is a quote from the presentation, and I want to drill down on some of the words that were used in this quote because they represent quite a interesting and large-scale engineering challenge in each of these words. So let's drill down and see. So we said that we want to give Netflix access to anyone wherever they are in the world. And that we already talked about 190 countries virtually anywhere in the world that you can go and access Netflix. We also wanted to give access to watch whenever. Now on the surface that doesn't sound very challenging, but servers never sleep, they don't get tired. But people do tend to watch Netflix a lot more during prime time. So there's a very definitive peak and trough behavior that we see. And these peaks and troughs can have a huge impact on network performance. So some networks may start to see a lot of packet drops, a lot of latency buildup during these peak times. So the whenever bit is really giving people the ability to stream consistently at any time of day, whether it's peak time or not. The other thing we said was that we will allow people to watch on whatever device they please. So this is another big interesting challenge because as we open up to the entire world, the device mix really becomes very, very huge. So there's a lot of different types of devices. They have different kind of computer. They're on different kinds of networks, and obviously giving a consistent experience across all these devices would be an interesting challenge. And finally, we said no more waiting. And this is where really the performance aspect comes in. We want to make sure that when you're ready to watch Netflix, you pull out your device or you sit in front of your TV, you're not waiting, and you're able to go in and watch your movie or TV show very quickly. So interesting set of challenges there. So how do we do this? I guess the first thing we started out with was measure everything. It's a very common theme. We want to measure doing how they're interacting with the application, how they're progressing through the application. And this translated into obviously a large amount of data that we started collecting. So we collect about 160 billion client-side data at this point. We obviously are about 135 million plus members across the world. And we already talked about the countries. And they are on 300 million or so unique devices. And these devices span 4 major UI platforms. So there's smart TVs, there's the website, there is obviously the mobile devices on iOS and Android as well. So as you can see, it's a very diverse set of devices, a diverse set of people in different geographies, producing a lot of data. The key thing that we really learned very quickly was that measuring everything is great, but what is more important is to measure everything consistently. This is really something that helped us a lot because if you measure things separately on TV UI versus web, the analytics that you can produce on the other side are of limited use and don't scale very well. And consistency was the key. We started focusing a lot more on consistency a couple of years back, and that's paid off huge dividends for us. So what kind of metrics are we looking at? So this is a animation of a TV UI startup. So you can see that the experience is pretty fluid. And you see that in about 7 seconds, you go from launching the application, browsing to the thing that you watched last, which is lost in space at this point. And then the video actually starts playing in about 7 seconds. So this is quite a good experience on a high-end device, on a high-end network, but not necessarily the same kind of experience is available to everyone around the world. And that's what we want to try and measure. We want to monitor things like this. We want to try and measure, quantify how people are experiencing Netflix around the world. So that brings us to the metrics. So that's what is the core behind what we're trying to do. Things like application startup times. So something that you saw there, it took 7 seconds to reach the video. Similarly, we look at how much time does it just take to launch the application and see the front page. And we do it consistently across all platforms. We look at play delay. So how much time does it take for a video to start playing after you've hit the play button? And then things like details page. So when you click on a movie, how much time does it take to display the details page of that movie? So this is just some of the metrics, but we have a whole bunch of metrics that we track across all these devices. Now, in addition to the metric itself, we have a lot of metadata around those metrics, and that translates to about 29 dimensions currently. We have a lot more dimensions, but we've kind of pared down to 29 key dimensions, and they span across geo. Obviously, we want to slice and dice across what country, what region, what city. We want to aggregate across those kinds of dimensions. We also want to look at network, so whether they were on a Wi-Fi or a cellular network, or they were on a high-end network in the US or a low-end network, maybe, let's say, in Indonesia. We also want to look at device characteristics, obviously. We want to see whether they are coming from a high-end device, or is it a low-powered Android device somewhere, which might be more affected by device performance. And then finally, we also look at A/B test dimensions. So whenever we release new features, we A/B test them, and we make sure that client performance is not negatively impacted, or if we are doing these tests for specifically improving client performance, we have the metrics available to kind of confirm out in the field that we have done what we had set out to do. Great, so we have all these metrics. How do we actually process all this data? So like we said, all these devices out there in the world, they're producing data and sending data over to a distributed log aggregation system. It's basically a REST endpoint. You can think of it as a REST endpoint, which receives log data from all these devices. Then this distributed system streams all of this data into Kafka. Someone has talked about a little bit of the architecture there. So that's the Keystone pipelines. From there on, we take the data and use a combination of Flink as well as Spark to aggregate the data. And this is where really, we take those 160 billion measurements that we do, and we enrich it with all the dimensions of geo, network, other things that we can infer from the various data points that we've captured. And then we also do the aggregation. And the aggregation is really the key, because we are using this thing called T-digest, which Matt will show you in action. And it allows us to slice and dice across all these 29 dimensions. And finally, once we had these aggregated data sets, it's still pretty high volume, high cardinality. We started thinking about how do we visualize this. We started off with a very basic mindset, and we tried to use BI tools like Tableau. And very quickly we realized that this is not going to scale. We're not going to be able to do the kind of ad hoc analysis that we want to do. And that's where, after a lot of thought and experimentation, we settled on Druid, and mainly because Druid gave us the ability to work across these dimensions, and not only that, but also plug in our T-digest module, which lets us arbitrarily calculate percentile aggregations across any of these dimensions or combination thereof. So this is really, our high-level architecture for publishing data into Druid. With that, I'm going to hand over to Matt, who's going to show you a little bit more about what we do from here on out.
Hello? Okay, great, that's on. All right, so my name is Matt Herman. I'm a visualization engineer here at Netflix. My job is to make data available and actionable to the business users. So, right, do your job, show me the data. Vivek had mentioned we had taken the traditional BI tool approach. That did not scale well for us. So now we have our data stored in a Druid cube. It's very high volume, very high dimensionality data. But it can be accessed via HTTP request, right? And we can hit the API, we can get our data back. So knowing that, we spun up a custom JavaScript application, which uses Node.js as the server and React.js as the front-end library of choice. So the first thing you might say is, okay, show me some data, right? Select star in the traditional SQL sense. Well, there are a couple problems with that. The first being, that's a lot of data over the wire. The second being, even if you can get all that data over the wire, that's a lot for the browser to plot, right? We're looking at 1 million points plotted in a scatter right now. Technically, that's cool, right? We can interact, we can play around with 1 million points. But what's the information gain here from a business user? It looks more like a pointillist painting than it does a business insight, right? So it's technically cool, but it gives us nothing. So where do we go from there? Well, we summarize. And Druid's really, really good at giving us aggregations. You know, we can slice and dice along dimensions like we've been saying all night. But also we can roll up. So here's a sample Druid query. What we're doing is we're running a group by query over our data source. We're looking to break out in our example just by country. So we're only looking at one dimension here. And then we're looking at our metric, our TTR, time to render. So let's remember back to Vivek's presentation when he played that Lost in Space clip. It took about 7 seconds in that example for our application to launch and our title to load and us to begin to play. So we're capturing our TTR summation, and then we're looking at the number of records per country. Again, finally, we're doing a post-aggregation, which is handling our division, to give us an average time to render per country. And we're looking at the last month's worth of data here. So we've got today, the 14th of November, back to the 14th of October. So what does that give us? Okay, we've gone from a previously unplottable and sort of nasty and large data set to, you know, about 190 points, right? Here we can see in our toy example, we've got the United States coming in with an average TTR of 2 seconds. That's a little off, but and India is coming in at 2.5. Perhaps the United States is a more mature market. Maybe there's better network connection. Perhaps India is a more emerging market. Maybe there's a different device composition, different network conditions. Tough to say. But okay, so now we've got some insight here, right? We know that the application is a little more performant in the United States than it is in India. So we're done. Let's go home. Well, no, not quite. Summary statistics are great for a quick understanding, but they can also lie to us a little bit. And this is most famously noted by a mathematician in the 70s, Frank Anscombe, who published his quartet. Anscombe's quartet, here we see, where we have 4 distinct data sets, all with different values plotted out, but the same summary statistics. So imagine a scenario wherein most of our countries are doing well, and they're all somewhat performant, and then the country you're in is doing horribly. You're not going to pay for the service, you're not going to have a good quality of experience, and you're going to have a bad time. So we can't plot every data point, but we can't trust summary statistics. So where do we go from here? We have to summarize responsibly with sketch strings. This is something both Vivek and Samarth alluded to earlier in their presentation. This is something that the Netflix data engineering team has been working on and is excited to give back to the community a little bit via open source. But what we can do here with our sketch strings, instead of computing an average, we can actually pass quantile buckets our sketch string operator and get back a corresponding array of our application TTR metrics at the 5th, 25th median, 75th and 95th percentiles. So what is a sketch string? In layman's terms, it's a hash that's recomputed at ETL time, which can be interpreted at query time in an aggregation to provide histogram buckets for values. Again, we're running over our country dimension, we're running over our same date range, and now instead of one data point per country, we've got 5. And so this begins to tell us a bit more of a story around the countries and how the application is performing in these countries. For those of you familiar with some charting techniques, this lends itself really well to a box and whisker chart. If we were just looking at medians, we'd say, well, you know, the countries are about the same, things are looking good. But because we have this distribution, we can see that country B, some of the folks in the 95th percentile, some of the worst performing applications, are actually having a much, much different story. So when it's bad in country B, it's really bad. When it's bad in country A, well, it's maybe not as bad as country B. But this is information we did not have without our sketch strings. So pushing this forward a little bit, what if we get a little greedy with how many percentiles we want back? What if we go each percentile or each tenth of a percentile? We can get a certain level of granularity here, which allows us to plot what's known as a cumulative distribution function, where we can compare different dimensions, in this case countries in our example, against each other for a very fine grain of percentiles. Again, for our application TTR metric. On our y-axis here, we've got our load duration in seconds, how long it takes for you to load the app up. In our x-axis here, we have the number of sessions loaded, or percentiles. So in a perfect world, everything would be hanging out down here in the bottom right-hand corner of this chart. Obviously, it's not a perfect world, and here we can see country B is a little bit more performant than country A. We're looking at the 99th 0.7 percentile. So we're getting towards the very far tail end of things. But you know, those users matter, those sessions matter, and it's up to us to win those moments of truth. So we've stepped through a toy example here of our countries, right? We started with a basic average, then we've pulled in a box and whisker chart, now we've pulled in a cumulative distribution function. But it's not too far of a stretch of the imagination to believe there is a UI where you can say, oh, give me country, or give me ISP, or give me device types, or give me a combination of country and device types, and give me a different date range, and give me a different metric, and really let users take advantage of that slice and dice functionality that Druid makes so easy. And that's kind of the analytical output that we've come to use here at Netflix. So just to recap, what Druid's allowing us to do is it's allowing us to ingest consistent and high volume and high dimensional data. It's allowing us to get at that data, to play with it, to slice and dice via custom web visualizations. It's also letting us summarize responsibly. It's making sure that we don't just throw an average out there and call it a day, that we give a distribution and paint a more clear picture. And lastly, really, Druid's helping us provide the best customer experience we can by being able to analyze our application quality of experience. So with that, I'm going to turn it over to Gian to talk more on the roadmap for Druid.
Thanks. Out here. And we're doing, excuse me, we're doing questions at the end. So if you have had questions for the previous speakers from Netflix, I don't know, write them down. I'll be done soon, I promise. So Druid, as I promised, roadmap community update. First off, who am I? Maybe I should have introduced myself before, but I didn't have the slide up yet, so I wasn't going to do it. I'm a committer and PMC member on the Druid project. I'm a co-founder at Imply, which is a company that's based around Druid. We do a bunch of products and services around Druid. The big ones are Imply Pivot, which is a slice and dice analytical UI you can use for Druid, and Imply Cloud, a managed Druid cloud thing. And I've spent the past 10 plus years working on scalable systems. So Druid, so we heard from the previous speaker, using Druid 0.12.2. Our latest release, just one dot after that, 0.12.3 is out right now, and 0.13.0 is what we're working on today in the community. So let's talk about what's going to be coming in 0.13.0, which, fingers crossed, we release in the next month or two. So first off, 400 new features and bug fixes from 81 contributors. Like most of our releases, it's got the most contributors and most things happening of all previous Druid releases, so really exciting. It's also our first Apache release. Druid has been running as an independent project for years, and recently, this year, after running for a few years as a pretty mature project, we started incubating with Apache so we can be together with our friends like Kafka. And 0.13.0 will be our first release under the Apache umbrella. So what is coming in 0.13.0 other than cool Apache stuff? So some of the highlights here, there's a lot of things coming. Like I said, 400 new things. This is, 8, I think. Native parallel batch indexing, phase 1. So when I say native, a lot of people like Hadoop. Druid integrates very well with Kafka and Hadoop. Those are probably the two tightest integrations that we have. Some people don't have Hadoop, but still want to load batch data. Maybe you're just in the cloud and you want to load from S3 directly. You're like, I'm kind of done with Hadoop. That's the past. I'm over it. So the ability to load directly from file systems, especially cloud file systems, without using Hadoop. Phase 1 of that coming in 0.13. Phase 1 is without shuffling. So if you want to do a partitioning function on your batch data, you're still going to want to do a Hadoop ingest. But if you just want to load data without having any shuffle, just load it, the way it's partitioned in your cloud storage, you'll be able to do that in 0.13. Automatic compaction. So that is, going through older data, adjusting granularity, optimizing older segments, that kind of thing. If you have small segments, combine them into big ones, doing that automatically. Phase 1 there. Phase 1 is it's going to not be lock-free. So it will basically get interrupted if you do an ingestion for that time frame. Phase 2, coming later, is totally background, completely lock-free, completely automated, and then you don't have to worry about it anymore, which is nice. We're always trying to increase the number of things you don't have to do. Ingestion stats and errors via an API. So this is really useful, especially for people that are just getting started, people that want to onboard new use cases, people that want to see what's going on in a cluster. Right now, if you have an ingestion error, you're going to be looking through logs, trying to figure out what's going on with the errors. In 0.13, there's going to be a nice API that gives you what the exception was and gives you stats about currently running ingestions. So that's cool. SQL system tables. So being able to introspect through SQL. Druid SQL is a big new thing that got added to Druid in the last couple of years. In the first couple of years of Druid, those JSON queries you saw in the previous slides were the only way to query Druid. Now you can query through SQL. And in 0.13, we're adding the ability to introspect the state of the Druid cluster, see all your segments, see running tasks, see what the servers are through SQL, making that a nice unified interface. Stay on the SQL theme. Null handling compliant with the SQL standard. Previous versions of Druid kind of handled nulls their own way, treating them like empty strings, so making that a little more standard compliant. Additional aggregators, a new hyperlog sketch. We had one in Druid, one's not enough, now we have 2. Support for, we're actually also adding, I like to hear about you guys adding a quantile thing. There was actually 2 other groups adding another quantile thing, so there's like 1,000 quantile sketches blooming. I think it's really cool, and there's a lot of, everyone's using a different algorithm, which is also cool. There's a ton of research going into quantiles these days and computing approximate histograms in quantiles. Druid's got a mechanism that does it today, but it's nowhere near as good as some of the new research that's happening. So I'm sure that your in-house one's a lot better than Druid's built-in one. So that also being improved. Support for multiple grouping specs in the group by query, able to do query fusion, so get your fine grain results and grand totals and subtotals all in the same query. So if you have a UI that shows a table and then shows a totals row, that could be done in one query in 0.13 instead of 2, saving a lot of effort. And if all your queries are like that, that's half your cluster load right there. And then back pressure and compact result formats for large result sets. So if you do have a Druid query where you are going to get 1 million data points for some reason, or 10 million data points, or 100 million data points, then 0.13's got some nice features to make that work a little better and give you more compact result formats. So that's 0.13. So that's, again, hopefully coming out next month or 2. And beyond. So this is something that happened after the 013 timeframe. This is 2019 stuff. And this is all sort of things. Some of these are being driven out of Imply, some being driven out of other people in the community. It's a total community thing. That's part of why we're going to Apache. Phase 2 of those first two things I mentioned, another smaller, faster compression. So another quantiles and histograms, one area a lot of research is going into. There's also a lot of people doing research into integer compression. It may sound like a kind of boring thing, but apparently it's not. And Druid, we pride ourselves on being really fast. That's what we're all about. And so implementing state-of-the-art compression techniques. Faster quantiles, mentioned that. So the two things being worked on now that I was aware of. I was not aware of what you guys are working on, but that'll be a third one if you do choose to make it part of Druid. So fixed spin histograms, it's the most boring one, but also the fastest. Just sort of, I have a min, I have a max, I have a bucket size. It's dead simple, super fast, but not adaptive. You have to know a min and max ahead of time. Moment sketches, some research out of Stanford that the team there published a paper on a few months ago, and in their paper they actually used Druid as a test bed and are open sourcing their work now. Dynamic prioritization and self-configuring deployment, those are two features that make it so when you set up a cluster, you have to worry less about care and feeding of it, worry less about configuration, have it work more out of the box in the way you want. And then your item here, it's a community project. Get involved. And you can try this at home. I am Druid, and you can too. We have a bunch of websites. We have the Druid community site, the current site, druid.io. Like I said, we're moving to Apache. You go to druid.apache.org. Right now, if you go there, all you're going to get is some words about how cool Apache is and a link back to druid.io. But at some point, that will change in the other direction. And then the Imply distribution, we have a distribution of Druid that is, it's basically the same as community distribution, but a little bit ahead in terms of patches and bug fixes. And it includes that UI I was talking about, the slice and dice analytical UI. Contribute, github.com/Apache/Druid. Here is a little screenshot. We're on GitHub. Stay in touch. So go to druid.io/community. There's mailing lists there. Chat channel, our Twitter, of course, GitHub, and you can join the conversation about Druid, participate in Druid, and you can follow us on Twitter as well. And if you want to work on Druid, we are hiring at Imply. I think that the Netflix guys are hiring for Druid stuff too, maybe, potentially. I don't know, ask them. And yeah, there you go. Time for Q&A. Do you want to join me back up here? I didn't mean to put words in your mouth, but it's okay. Questions? Does anyone have a microphone running around? Heroes in front of you.
Any plans for the UI? I know it's integrated into Imply platform right now, but any plans of bringing it out and making it open source?
Stay tuned.
What's the difference between sketch string and the existing quantile sketches in Druid? Can you elaborate? You said that you use sketch string for quantiles. Just wondering how that's different from the existing quantile sketch and.
We use the Netflix histogram module, so it's our own implementation based on T-digest. I think what's there in Druid is a different algorithm, like you were mentioning.
Yeah, so Druid's gotten a proxyscript module. That's something that we made up a few years ago. I forget what it's based on, but it's not as good as T-digest.
T-digest is you can read about it. It's written by Ted Dunning. So you can read about the open source implementation of that.
Some of the new ones out there, there's one out of Yahoo that's part of their data sketches. That's also a new algorithm, and then there's Stanford one is a moment sketch algorithm that they.
I mean, yeah. The reason why I was asking was so we use the quantile sketch from the sketches library. It worked pretty well. I was just trying to understand, if you compared the difference between yours versus existing quantile sketches. and if you saw any improvements and stuff like that.
Yeah, so we definitely had cases where, so it's an approximation, right? The quantiles are an approximation, and every time you run the query, you get a slightly different answer. And the point is to narrow that gap down and make it as accurate as possible. So we worked with Ted Dunning a little bit to improve the accuracy with T-Digest, and we found that that has worked better for our use cases, and it's a little more accurate. But there's obviously more improvements that can be done.
There was a question on, I don't have a question, I have a comment. There was a question of the UI. We at PayPal, we have been using Druid for Grafana with the Druid plugin. In fact, PayPal is one of a contributor for the Druid plugin. That has been working out so well for us. Thank you.
So my question is around rollups. We are using Druid, and we have hourly aggregations there. When we want to aggregate the data to daily basis, in Druid right now, it's basically based on UTC. Is there any way we can support a lot of different time zones and say, we did roll up, but we can serve our analysts in PST time zone and then someone from EST or some other different time zone?
Yeah, so that's a very good question. When we ingest the data, we ingest it all in UTC, but we also have a dimension for the PST timestamp. Unfortunately, there's no, at least I'm not aware of any good way of using the Druid indexer to do that, short of creating a new index. But we have it as a dimension in case we want to fall back on PST.
Talking about you're doing it a day granularity, but you just want to have 2 time zones and not. Yeah. I think the way you're doing it is probably the best way. If you want it every time zone, you might as well just do hour, and then you'll get every time zone.
My understanding is that Druid scales really well when you have a lot of data coming through a small number of data streams. But what happens if you need to have thousands of data sources? Does it scale up that way too?
Yeah, good question. So if you have 1,000 data sources, Druid's it's kind of like Kafka in that every Kafka topic has a bunch of files that are associated with that on disk, and Druid's like that too. And so for kind of the same reasons as that system, it prefers to have a smaller number of bigger data sources or topics as opposed to a large number of small ones. So it would probably make sense if you had on the order of thousands to combine them into bigger data sources and have a column that says what the data, what you think of as a data source. So maybe you can put them into one Druid data source.
If you can't do that, would it still work or would it fail? Let's say you have a couple thousand data sources. Some have very high volume and a lot of them have very low volume.
It would work. It might just not be as efficient as combining them into combined data sources. The biggest, in terms of the just raw number of data sources, the most I'm aware of is on the order of thousands. And it works, but the folks that run that cluster, I keep trying to convince them to combine them.
Hi, sorry. I'm new to Droid, so this might be an easy question. What's the comparison between Droid and Elasticsearch? Second question is, what you said you can cover time series data pretty well. What's unique about the time series data related features?
Yeah, definitely. I guess I can take that one. So for Druid and Elasticsearch, I would say the biggest differences are that, so if what you're doing, if you want to do, so both Druid and Elasticsearch have inverted indexes. That's kind of the search concept. If what you want to do is full text search, Elasticsearch is based on Lucene, so a bit more sophisticated in terms of the full text search capabilities than what Druid would have. Druid's more of like, it supports inverted indexes and I'm searching for individual terms, but it's not going to have the full Lucene query language. On the flip side, the analytical stuff you get out of Druid is a lot more advanced than you get from Elasticsearch. So you have people like this and people like other folks in the community just contributing a lot of stuff around doing fancy kinds of aggregators and fancy analytics. And also in Druid, you have a really tight integration with Kafka. So if you are using Kafka, we can pull data out of Kafka without having any sort of middleman or anything like that. It's exactly once and really nice stuff like that. And your second question, sorry, I don't remember. What was it? Yeah, your second question was about time series data. What about time series data makes us say that Druid's optimized for time series data? So it's a distributed database, and when you're making a distributed database, you always have to partition by something. And in Druid, the partitioning is always based on time. So you provide what we call a partitioning or segment granularity, which is a partitioning granularity. So whether it's hour or day or month or whatever, you're partitioning based on that. And then we have a lot of optimizations in Druid built around time. So when you're doing filters on time or grouping on time or anything around time, that all goes through optimized code paths. Definitely.
So like one of the feature we saw was like nested group by. So can you give us more insights on that? And like say we have many use cases surrounding that. And like what level of nested? Say we have a nested group by, and within that, can we have one more level of say nesting?
Yeah. So nested group bys, just to be clear, in Druid, nested group by refers to doing aggregations on top of aggregations. So you might use that to compute something like daily active users, or you might use it to do an exact count distinct. And you can have as many nested levels as you want. The levels beyond the first one, so the innermost level runs on the historicals and indexers, so the data servers, and then higher levels are on the query broker. So I guess the only insight I would have about nested group bys is you want to think about how much data is being shuffled from the innermost level to the higher levels, because that's going to go through one server at this point.
Hey, I was going to ask, is Tranquility still a supported library? I thought it was deprecated.
Very good question. It is, there was a thread about it on the Druid mailing list, the community mailing list, which is the best place to get this kind of information. The thread was basically someone asking that question, and I think the conclusion that we reached as a community was there's a lot of people that are interested in maintaining it, so kind of fixing bugs if any are found, making it work with newer versions of Druid, but no one had stepped up to be interested in really driving it forwards in a big way. So because of that level of interest in the community, I would consider it probably in maintenance mode. The thing that people have been migrating to is the native Kafka integration, so Druid pulling data directly out of Kafka. The computation engine? Yeah, so the question was, what is the computation engine inside of Druid? It's total ground up Druid's own thing. So Druid has its own storage format, and it's got its own computation engine, and it's got its own data distribution algorithms and engine. So it's everything is Druid. We don't. Yeah, everything on the inside is, there's some individual algorithms that we take from places, but the processing engine and the data formats are all homegrown.
Can the Druid applications sit in the same cluster as my Hadoop cluster, hoping to consume the Hive table in place? Or that's not how it's. I'm new to Druid, so is that an optimum way to use it?
So when you say Druid, you mean the Druid cluster, the Druid servers?
Yes. So I have an existing Hadoop cluster, and I have the data sitting there. And I was wondering if I could just install Druid into the same cluster and have that ingestion local, or does it need a separate cluster for Druid versus the Hadoop Hive cluster?
Got it. I see what you're saying. I would say it's most typical to install Druid on its own machines. Do you do any co-location of Druid with other stuff? Yeah, it's most typical to install it on its own machines because, so we're talking about doing super fast slice and dice on big data tables that have billions or tens of billions or trillions of rows in them, and it's memory and compute hungry. So Druid tends to give it. It tends to take all the resources you'll give it.
About the lookups feature, I didn't see anything in the 0.13 talking about bringing lookups into more mainstream, because I still see it as an experimental feature. So I'm curious what your thoughts on that.
That's a good question. So in the Druid community, we're very conservative about removing experimental labels. I would say that lookups, there's some stuff that a lot of people use them. I mean, so they're a very widespreadly used feature. There's a couple of things that I would want to tweak about them. I didn't talk about them here, but I don't know. We can get into the details later if you want. But they are a very widely used feature. So yeah, the question was, can you do more than one timestamp column while specifying the schema? So in the partition, so Druid asks you to specify a timestamp column because it is going to partition your data based on that. So the one you specify is the one you're partitioning on. You can have more than one. So like you mentioned earlier, you can have another one. Druid would just treat that as a regular dimension. That's it wouldn't think of it as a timestamp internally, but you and I know it's a timestamp.
It as a dimension. Yeah. So we have dimensions for PST timestamp, UTC hour, UTC date, PST hour, PST date, just as additional dimensions.
But
yeah, and sorry, go ahead. Sorry,
but know that dimension, when we specify the time range that we're running our query over, that you cannot use that dimension there. It's the only the partition column.
Yeah, so one of the timestamps will be special. It'll be the one you're using for partitioning and interval filtering, but the others, you'll still be able to use the others.
So full disclaimer, I'm new to Druid and trying to set it up in our POC environment. We talk about high cardinality for the data that is coming in, and then we might be having like tons of dimensions as well. How many dimensions are too much for Druid, and how do we measure that, and what statistics I should be looking at to see that that's my breaking point?
All thoughts around that? You talked about modifying the number of dimensions in some of the data.
I would say that preparing the data might be your bigger challenge. You may want to push 1,000 dimensions, but managing those dimensions in your data pipelines itself will become very challenging. And that's partly the reason why we chose to pare down the dimensions and focus on the 80% use case. And we settled on about 29 dimensions. And it was not because Druid can't handle more than that. It's mainly because on the data side, it's just much more easier and more consistent to push, manage fewer dimensions, and it's even easier on the usage side. Otherwise, it just becomes really hairy.
Yeah, I'm sure Druid can scale wide, very wide, but as a user, I can't imagine being confronted with, that many pickers or that many options in a pick list and being able to sort through that.
So you don't want to, of course, include account ID as a dimension, for example, because you won't get any roll up then. So you have to be cognitive of the cardinality of a dimension. Extremely high cardinality, like account ID, user ID, Druid is not made for that. Thanks.
Yeah, some people do it, but it's definitely not the typical case. Yeah, I would say that the typical number of dimensions is probably in the 10 to 150 range is your sort of that's your solid middle ground. And the most I've ever seen in a data source was actually 18,000, but that was a weird case. That was a case where not every segment had the same. Not every segment had every dimension.
Just to add,
it was really sparse.
So we have a cluster with about 120 metrics and about 40 dimensions, and cluster net works fine. So.
Other questions? Oh, you have one in there.
Yeah, that's a great point. So Caravel, which is now Superset, treats Druid as a first-class citizen. We had a proof of concept of that at Netflix. We decided against it, primarily due to the reasoning, but also keeping our users sort of on the rails a little bit in terms of the queries that we want them executing. Superset, you can drag and drop and kind of do whatever you want, but we wanted to give more of a tailored analytical experience via a custom. But that is a reasonable approach and question.
Just to add to that point, though, I think one of the use cases that Samarth was showing about the experimentation tooling, you can build experimentation tooling front end with Superset. I can't imagine you building an experimentation, but for analytic use case, I think you can. So, but even for analytic use cases, when we tested it out about a couple of years ago, Caravel was still called Caravel. It was, we found some challenges around, if you want to give business users functionality or charting or analytic output, we found like building a custom UI might give you the more flexibility versus having them pick the charts that they want, which ends up being Tableau again on top of, yeah.
So in the case where you're dealing with smaller data sets, would Druid still be able to perform significantly better than other types of programs that you could possibly use, maybe like Tableau or something like that?
I would say that that Druid, in the Druid world, so some big data things have a reputation for, like there's posts on Hacker News saying things like how I sped up my Hadoop job by 200x by running it using Bash. So some big data tools have a reputation of not working well in the small. Druid, we spend a lot of time on optimization in both the large and the small. So you'll find that Druid running in the small is generally going to be as fast or faster than things that are not big data tools, that are custom built for this kind of stuff.
In terms of the visualization, I cannot in good faith recommend building an entirely custom web app for small data if that need can be met by traditional BI tools. It's just it's a trade-off. It's a time investment in building a custom UI versus going with something that's already spun up for you. So maybe in the small data, for the rendering of the information, you may want to consider.
The follow-up on the earlier questions, maybe stepping back a little bit for the new comers to the Druid, what product gap you're trying to fill? So I think you mentioned a little bit earlier. One is, you seem to do better with whether it's a small amount of data or large data. And you seem to replace the Tableau with the more scalable and more dimensional analytics. So if you could elaborate a little bit more on where, with the Hadoop ecosystem, there's so many tools. So which hole you're trying to fill? And also, it sounds like you have very good analytic capability. And in that case, how you and the Spark might be with the Druid coming on the roadmap?
Yeah, I can at least talk about my perspective, if you guys don't mind. Then you can talk about maybe why you're using it. My perspective on that is, so we originally created Druid in order to power slice and dice analytical UIs like the kind you guys are building. So this is solidly in what Druid's designed to do. And the gap we were trying to fill was so Druid is there's not a visual component to it, which is why we're talking about custom UIs and superset and imply pivot and whatnot. But it's a data store that does really fast slicing and dicing and integrates with Hadoop and Kafka. And the idea is that you might think, if it integrates with Hadoop, why not just use Hadoop? Why not just use Spark? The main reason is because once you actually load in a big data table, so tables that are billions and billions of rows, it's really tough with an architecture like Sparks or Hadoop's that's general purpose to get human time sub-second responses, and that's really what we're trying to do. We're trying to make it possible for, in order for these UIs to be responsive, you need to be able to get queries done in human time.
In our use cases, we maintain the data in Spark and Hive as well. So there are users who go directly with Spark doing their own analysis, but Druid is kind of a way to serve a front end, basically, and let people slice and dice with the custom kind of look and feel. We have both, yeah. Yeah, so actually we have the fact level data, which is what we had shown earlier, which we collect from the users, and then we aggregate it. We store that as well in Hive, and then we push all that into Druid so that we can enable this front end to kind of interactively do this slicing and dicing. So I would say that the interactive use cases are mostly for dashboards, for management reporting. There's also use cases where people want to drill down into one specific region or one specific A/B test, and they want to do much more detailed analysis on those users. In that case, people will use Spark or they'll use Presto to query the data directly, either the aggregated data or the raw data itself. So it's a scale of sophistication, I think.
I have some questions. Just beside those analytics or UI cases, do you have any other use case using like just data science or AI? Big database, Druid can be used, applicable. Like a time series, for example, anything, any use case you have been using Druid in the case.
Thought about any of that?
We are using this data. We are doing some models to do things like segmentation, so device segmentation, or trying to predict what the characteristics would be. We're not necessarily using Druid per se, but there's really nothing that would prevent us from using it. It's just that we have the data available in Hive and Spark, so we just use those.
You could do some kind of real-time monitoring.
Right, real-time monitoring, and also, for say data science or AI, sometimes we need to do data like a pre-process or post-process analyze, right? Just see if any use case you have been using, Druid in this. Not, that's fine. Thanks.
I would say real-time monitoring is really common. I don't know a lot of people that are doing AI-related stuff with Druid. The people I know that are mostly using Druid to gather data that they're going to use to then yeah, that's it.
So we deal with the late arriving data on the data ETL side. We don't rely on Druid for that. Druid will finally get the daily or hourly push. So if we have to, let's say, update an hourly push with some late arriving data, we just re-push the entire hour. And that's mainly to make it really quick and easy. We don't have to worry about deltas or anything like that. And we've seen the performance is really good, and we don't have to worry about it. So we just re-push the entire hour if we have late arriving data, and we go on from there. Follow up on alerting? Yeah. What was the question again? Sorry.
How can we integrate?
So we don't really do alerting and monitoring through Druid. We do it at the data layer itself before the data lands in Druid. That's just an architecture choice. I don't think it's Druid technology limiting us. We could have done it on Druid if we need.
I mean, you can easily build an app around, so if you're doing real-time ingestion of Druid, right? I mean, last 15 minutes of data, you see on what you expect, you just fire off a alert. So it's easy building.
On the routers, like having multiple brokers for multiple different use cases, right? Like say, how did you go about designing it? Like say, major use case, like this is what the spec of a router will be, like broker will be like. Can you please elaborate on that?
So what we have primarily done is at the level of data source. So we know certain data sources are used by our dashboards. So we say for these set of data sources, use the reporting broker. Fall down to the ad hoc broker. No, it's the router decides which broker to forward the query to, right? And so we don't have any sort of multi-tenancy at the historical level. It's mostly at the broker level. So all the brokers still use the same set of historicals. Yeah. Yes, if caching on historicals, yes. Yeah. They're mostly historicals, really. Yeah.
So I just wanted to add something to the question about the use of Druid with AI. I actually found good use for it. Using the roll-up, the real-time roll-up during ingestion to take large volumes of data and actually compress them so that you can query them in near real time and then continuously be updating the model more quickly than you would have been able to otherwise because you don't have to process as much data. So basically just using Druid to do the real-time roll-up. And it worked pretty well.
Nice, thanks for sharing.
One question there and one question there. Up for time.
So how many queries per day do you guys do on your clusters?
Sorry,
depends on the day. Yeah, some days are very heavy. I don't know, like I don't think we have a number per se, but it's very variable, I would say. Yeah, there are days when there are incidents or other things going on which require a lot of dashboard usage or real-time data usage, and the query volumes are very different on those days. And that's partly the reason why we split off the brokers in order to, on a normal day, we don't need the split, but on high volume days, we've seen that, having that split helps us be more resilient.
I would say that if you're looking for just sort of numbers around what scale makes sense, Druid it's an analytical system, so it's not a system that is designed like a key value store to handle millions of QPS. I would say that most normal Druid clusters are doing somewhere in the range of like 1 to 100 QPS. I'm not sure if that's jiving with your experience. And I would say like a high concurrent Druid cluster is maybe 1,000 QPS. I would call that high.
Okay, so the question I have is comparing, the aggregation rollup. How do you have anything between, say, a Spark, Kafka, K-Stream, versus, time and performance? Anything you have something you can share?
So you're mentioning KSQL and Druid. Were you interested in sort of thoughts on how those relate?
Not even actually. KSQL is more newer actually. Before that, just a K-stream itself, just to just application level, the processor to the real-time aggregation roll up, and also that's kind of comparison I'm looking at between like Spark, K-stream, and also Drill, how we can applicable. Because I'm also looking at beyond just the analytics reporting UI, but also on the microservices or process for AI machine learning, how we can see.
Yeah, I would say that that stuff like KSQL and KStreams and Spark streaming, people often talk about them when they're talking about streaming or real-time analytics, and people talk about Druid too. And there's one big difference there, which is that stuff like Spark streaming and KSQL and Kafka streams there's basically stream processors. They sit on top of a stream and they process it and they continuously compute a query. And so they might continuously compute. You might set up a dashboard where you have a dozen queries that are continuously computed, and each of those continuously file in the dashboard. And then you have a dashboard that updates in real time, but you don't have the ability to drill into it because it's just coming from these continuously computed queries. And what Druid is a system that is, if you want to be able to drill into those things and slice and dice across a bunch of dimensions, then Druid's not a stream processor. It's something that's actually loading data into itself. It's a data store, and then it integrates with Kafka not by processing the stream, but by loading the stream and then running queries on everything it's loaded. And same with Hadoop. It integrates with Hadoop by importing data from Hadoop into Druid and then querying all the data that's imported.
Right. I think that's all the time we have for Q&A here. But
Awesome.
we encourage you guys to hang out outside and find us there if you have additional questions.